All right, welcome back. We're going to do some examples of our last simple machines, incline plane, wedge, and screw. I'm just kind of going through the simple machines practice problems. The main thing I'm going to do is make sure that we have our setup correct, because at this point we've done quite a few simple machines problems. You should be able to do mechanical advantage pretty well on your own, so I'm going to make sure you at least can just see what's going on. So I have incline plane problem. A civil engineer must design a wheelchair accessible ramp next to a set of steps leading up to a building. The height from the ground to the top of the stairs is 2 feet. Based on ADA codes, the slope must be 1 to 12 or less. Slope is equal to the rise of the ramp divided by the run. So how does that work? Let's get things set up. So I've got a ramp, which would look something like this. This would be L. This would be R. Or run, I guess we could say. This would be my rise. And so in my up above, it says that my height from the ground to the top of the stairs is 2 feet. So I'm going to call this 2. So there's my picture, okay? Using ADA code, what is the allowable minimum length of the ramp base? Well, they told me that slope is equal to rise over run. And so rise over run, I need to figure out what the minimum length of the base is. Well, that's my run. So I'm going to rearrange the equation and say run is equal to, this would be multiplying run up over here. So if I put run over here, then slope would have to replace it over here. So I would say rise divided by slope. So that would be equal to 2 feet divided by 1/12, because 1 to 12 is what my slope was. So if I take that, my answer ends up being 24 feet. Okay, so I know the base now is 24 feet. So now that I know the base, they want me to know what is the length of the slope of the ramp. Well, from my notes, hopefully you remember that if I have a triangle and I need to do that, figure out the angle of the slope or the length of the slope, that should trigger something a squared plus b squared equals c squared. It should be just ingrained in your head, Pythagorean's theorem. Okay, so we'll write down that's our equation and go from there. So we'll say c is equal to the square root, and we'll say a is our 24, so we'll say 24 squared plus 2 squared. And if we work that out, our slope, or L, is going to be equal to 24.1. Maybe you say 24.08 if you want to. Okay, 24.08. So from there, then we just use our IMA equations, right? IMA equals L over H. So I'm not going to do that for you. You guys can figure out what that is. And then for the last one, once we figure out IMA, then we use IMA equals AMA, just like before. And you should be able to figure out what's going on there. And if you want, I could just rewrite it. You could take the exact number and plug it in down here, or you can say L over H is equal to FR over FE. And then you would figure out, plug and play and solve, and go from there. Okay, so you have your setup. I did most of the problem for you. I want you to work on filling the rest in. Okay, here's the wedge problem. The wedge is kind of strange. The wedge is a hydraulic shear applies a 2,000-pound force to a wedge. It's used to shear a plate steel to rough size. The shear is a 1/4 inch thick cutting blade with a 45-degree slope. So that means it's a 45, 45, 90 triangle. That's a lot of words. So basically what they're trying to say is my shear is something that kind of looks like this. Okay, this triangle right here, it tells me that my distance here to here is a 1/4 inch. And because of the slope of this angle here of 45 degrees, that means that this triangle is a 45, 45, 90 triangle, which means that the rule of triangles just means that this 0.25 then means that the height of my wedge is going to also be 0.25. That's what it's telling you. So you have a triangle. If we rewrite this, you have a triangle that's 0.25, 0.25. Now it's asking you what's the length of the slope here. I don't know why they're asking you that, because the height of your, or like this distance here is what matters for your mechanical advantage. But again, this is just going to be your Pythagorean theorem. Okay, and you'll plug and play and find your length there. But then your ideal mechanical advantage is actually just going to be using the 0.25 and the 0.25 since it's a wedge. Okay, and you'll figure out your ideal mechanical advantage and solve from there. Pretty easy. The last one is a screw. The screw is saying a 7/16 nut driver. So instead of a screwdriver, they're using what's called a nut driver. It's like a screwdriver, but it uses a little like nut head, kind of like on a ratchet set or something like that. And you're driving a screw like that. And so they're saying that this diameter from here to here is 1.5 inches, and the threads per inch then is right here, which is 20. And those are the important dimensions, because then for your circumference, you're going to use your 1.5, and for your threads per inch, or your pitch, you're going to use your 20 as you go down here. So they're going to ask you, what's the circumference where the effort is applied? Well, that's using your 1.5. So circumference is going to be equal to pi times diameter. The pitch of the screw is equal to 1 divided by threads per inch. And then IMA will be equal to circumference over pitch. And then again, now you're going to use AMA equal to IMA to figure this out. So you'll have your IMA, I'm going to write it backwards this time, is equal to FR over FE. FE is your 5-pound force. So plug in and solve, and you should be good to go. Good luck.